Hi, I'm Jason. Welcome to the first of a series of videos on running an EMCO Compact 5 PC on LinuxCNC. Other than the tool head, which I changed because this one only came with one tool holder, this is a stock standard EMCO Compact 5 PC. There are a lot of great mods that you can do to make these even easier to use, but as this is targeted at school teachers who are likely lacking the time and money to do those mods, and it's not my lathe, I'll be sticking with an out-of-the-box lathe for this series. The original software for these lathes runs on Windows XP and requires a dongle which has most likely been lost, as is the case with this lathe. The goal of this project was to get the lathe working quickly, easily and cheaply with more modern software. There appear to be a few options in that space, and I chose to try LinuxCNC first because a few others had had some success with it before me. Now I'm also using AutoDesk Fusion to generate the NC files, as I'm familiar with it and it seems to work well. I'll go into the detail of that process in a later video. So to do this, you're going to need a computer with a parallel port and not a USB parallel port adapter. They are too slow. It will not work with this. You'll also need a USB stick and internet access. Now first up, we need to find a suitable computer. The EMCO uses the computer to directly generate the individual pulses for each of the stepper motors. It is totally dependent on the computer. It doesn't load the program and then go and execute it independently. So LinuxCNC uses a special real-time kernel so that it has the best chance of creating the necessary pulses at the right time, but you still need a computer that's going to keep up. Now I've been successfully using school computers that have been diverted from scrap, so you don't need anything ridiculous. However, my machines have occasionally complained that they can't keep up. So I'm going to try something a bit gruntier this time. I have an old HP Z210 workstation here, so it's circa 2010, so only 14 years old. It has a Core i7-2600 and 8 gig of RAM in it. Now you will need to download a copy of the LinuxCNC ISO and burn it to a USB. I won't go through the detail here as there are some great instructions on the LinuxCNC site and the URLs down below. So before we go to the trouble of installing, we'll boot from the USB and test the machine to make sure that it's going to be suitable. So we'll boot the PC, and on this particular machine, if we hit escape, then it should give us an option to select our boot device. There we go. Now, if you are using a school PC for this, you probably won't have the option to boot from a USB. So you can see here we have the generic flash disk. Now, if you don't have the option to boot from the flash disk, you'll probably find that there's a password on the BIOS, so you can't enable it, and you'll have to reset the BIOS to get to it. Depending on your computer, there are a few different ways to do that. This particular computer has a button that you press. There could be a jumper that you need to short out, or you can just take the CMOS battery out. So I'll have a look at that in a minute. For the moment though, we have the option, so we're just going to boot from the generic flash disk. And you can see we have a LinuxCNC screen, so we just hit the enter key to proceed. Okay, once the unit's up, we'll just go into the applications menu and CNC latency test. Now we want to run this for 5 minutes or more, and as the window says, abuse your computer. So it's helpful if you've got some video files or some WAV files to play. I'll just fire up a web browser, so applications, web browser. And we'll go to YouTube. So you can see the latency test is measuring the maximum jitter and intervals for the servo thread and the base thread. The one we're interested in here is the base thread, so it's reading 21986 at the moment. So let's see if we can run it a bit harder. let's have a look for something on YouTube. Let's have a look at some Stumpy Nubs videos.
Switch to Chrome to load your favorite sites fast.
And
browse with ease.
don't really need the sound for this.
Safe.
Okay, you can see that the base set's jumped a little bit. Wiggle some windows around just to give it some thinking to do. I'll fire up a few other things. Let's go File Manager. Package Manager. It's okay. And if we jump back into our web browser and go to the LinuxCNC latency test page, so I'll just search for it here. So this tells you what values we're looking for and what the test is all about. So if we scroll down to here, you can see that the maximum jitter we're looking for is something less than 15,000 to 20,000 nanoseconds. So if we have a look back here, we've got 22, so we're pretty close. We should be okay. So very nice results with that. If the maximum latency is more like 30 to 50, then you can still get good results, but you might not get the maximum step rate. So that's probably enough of that. So note down that base thread maximum jitter number, so 21986. Now the other thing we can do, back on that latency test page, it also has some tips on things that you might be able to do to improve your latency. So definitely if you're close, have a look at that, and we could probably tweak this machine to get it in under 20,000 as well. So now that we know that the computer's going to work okay, we need to put a parallel port in it. So we'll shut down the computer. Okay, move our monitor out of the way. And remove our power cable from the back. Now while we have the lid off, I'll just point out the CMOS reset. So this one has a button just in here. So I'll zoom that in so we can get a closer look. Okay, so that one there, so you hold that one in for 5 seconds and release, and then you can close it all up again, power up, and you should have no password on the CMOS anymore and be able to boot from USB. Now, other machines, you may have to use something like one of these jumpers. There may be a header that you need to close on one of these jumpers, start your machine, shut it down, open up again, remove the header, and then start your machine up again. All that information should just be in the manual for your computer. Now, let's have a look at the parallel port. Now, this particular machine actually has a parallel port header on the motherboard, but I could not find a breakout connector for it locally, so I went with this startech.com PCI parallel port adapter that my local computer shop had in stock. So we just need to, in this case, we need to flip this open, remove a blanking plate, seat our card, clamp shut, and pop our lid back on. So with the computer boxed up now and the anti-static mat away, we can now install our LinuxCNC. So USB drive in, and escape to get our boot menu. So back to the boot menu again this time, and flash disk. But this time we want to go down to Start Installer and then hit Enter. We'll go English. Australia. Keyboard is American English. Our host name, to keep it simple, I'm going to call it LinuxCNC. And that is my local domain. User account, we'll go with the same. And the same again for the password, because I'm not too bothered about security of this account. New South Wales. Okay, and we'll just use a guided entire disk and the 1 terabyte. Doesn't matter too much what we do here. We'll just go with all files in one and then continue. Okay, we want to write the changes to the disks. And then wait for it to install. I don't have a proxy here, so we're just going to continue. Now, bootloader, I guess it's probably safer to install to the FI removable media path, so we'll put it in there. And we definitely want to boot this when it starts. So we'll continue there as well. And we're done. So continue to reboot. And we're ready to go. Now the first thing we should do with a new system is update it. So let's just open a terminal and type sudo apt update and then a password. Okay, now you can see we have 88 packages that need to be upgraded. We also have an error in here. So it looks like there's a signature bad. That is in Etherlab, which we aren't using. So we can ignore that one. I'll have a look at how to fix that one later and add that in the notes down below. So for the moment, let's go and apply those updates. So sudo apt upgrade. And yes, we'll continue. And that's done. So we can have a look at the sudo apt update again. And all packages are now up to date, so we're good to go. Now LinuxCNC is a very capable application that can control a huge variety of machines. So that means the configuration can be pretty complex. So thankfully samco from CNCZone has done a lot of the heavy lifting and posted his config files. The link's down below if you want to get a deeper understanding of how he came up with them. Now I've updated them to work with the current LinuxCNC and changed them to metric. So you just need to download and drop them into the config folder on your machine. So let's do that now. We'll start with the LinuxCNC launcher. So find it in the applications menu, CNC and LinuxCNC. And you can see there are a number of different configurations in here already. These are all simulations. So we'll get LinuxCNC to create our folder structure for us first, just to make sure it all gets done properly. So we just go into Sim Axis and pick Lathe as an example, and then OK. And you can see it's going to copy the configuration to our home directory. So let's do that. And then LinuxCNC itself will start up. So this is what our interface is going to look like once we get our own configs in there. So we'll just close that for the moment. And yes. And now if we look in our home directory, you'll find a LinuxCNC directory. And the configs folder is where we put our lathe configuration. So let's just open the configs folder. And the sim.axis is the simulation we just created. Now, to download our configs, we'll fire up a web browser and go to my GitHub site, so github.com/floodj, and jump onto the EMCO Compact 5 LinuxCNC Fusion 360 project. Okay, now we can just download the zip of all those files. There we have them in the downloads. We can close that now. Let's open up the zip. And go into the LinuxCNC folder, and we'll just drag the EMCO Compact 5 PC folder into our LinuxCNC configs. Okay, and we can delete the simulation one now. That's done its job. If we look inside this folder, you can see there is a full step folder. So there are two configurations that were created by Samco. At this stage, I've only tested the full step. He also has a half step version, which I still need to configure to make it work with the current version. So at this stage, we only have full step. And you can see those are the configuration files. Now, while we're looking at the config files, we need to check that we have the correct address for the parallel port. That can change depending on which card you've used. So we'll search the logs to find it. So we'll fire up a terminal once again and maximize that. And we want to run sudo dmesg and then pipe grep par. So that will find any instances of par in that log file. Give it our password, and there we go. And you can see that we have PCI parallel port detected, IO at 0xD010. That's what we're looking for. So if we now go into the EMCO lathe.hal file, and you can see on this line 11, insert parallel port base address, 0xD010. So that's where, if you come up with a different address, you'll just need to modify that line 11 to make it match yours. So if we close that now, we can go back to the LinuxCNC front end. And under my configurations, we now have EMCO Compact 5 PC and a full step. So this time let's create a desktop shortcut. And pick the EMCO lathe. And there we have our EMCO lathe interface. So now we're ready to actually plug it into the lathe and see if it works. So because I don't know how well protected the parallel port is on the EMCO, or on the computer for that matter, we'll shut the computer down first before we plug it in. Well, the parallel cable's plugged into the lathe now and the computer's fired back up again, so it's time to smoke test. Now before I test anything else, I'm going to make sure that the emergency stop works. So I've checked that the chuck's turning freely, so that's good to go. The guard is down, safety glasses on, and so with one hand on the emergency stop, turn it on and let it warm up. And then rotation, and the emergency stop works, so we're good there. Now let's start up our lathe front end, so EMCO lathe, and you can see that it's not trusted, doesn't trust that link. So you can select mark executable, which I have found doesn't always work. So what you can do if that doesn't work is just right click on the icon and properties, and if you go to permissions, allow this file to run as a program and close. Oh, it's timed out, and let's just go to launch anyway now. Okay, and you can see that we have our manual controls here, but they're all disabled. So that's because we haven't actually turned the lathe on yet. So let's do that first. Again, hand on the e-stop and turn on. That looks like that's working fine. And so now we just need to enable the machine power in LinuxCNC. And there we have the controls now. So we have controls for X and Z, and if you look down below there, we have the jog speed, 150 millimeters per minute, and the maximum velocity at 600. So let's try jogging the X-axis first to make sure we got that one right. Okay, and that's jogging fine, out. So positive is away from the center line. We'll jog it back in to the center line now. That's working fine. Let's try and wind up the wick a bit. So if we take it to 600, let's go out again. And that's looking very good. Okay, time to check the Z-axis. So Z-axis, positive is towards the tailstock. So let's try positive Z, negative Z. So we've built our PC, we've got it connected up to the lathe, and we've proven that our axes are moving correctly. So in the next video we'll look at some more detailed configuration of the lathe and Linux CNC and start turning some things. Thanks for watching.